Today we're going to learn how to analyze the function from an equation. So the first thing we're going to do is find the domain. So there's only three situations that we're looking for when we're looking for the domain. The first situation is when you have a rational function, which just means it's in fraction form, in which case your denominator cannot be equal to 0. The second situation is when you have a square root, and we know that square roots, what's inside the square root has to be greater than or equal to 0 because you cannot take a negative square root of a negative number. The last situation, which we're really not going to use, but I just want you guys to know about it, is a log. You can't take the log of a negative number or 0, so that has to be greater than 0. So these are the three we're looking for. If neither of these three apply, then your answer is always going to be all real numbers, which is negative infinity to infinity. So it could be anything. Which a way of writing this mathematically is this R with a line through it. This represents all real numbers. So let's take a look at these problems. So number one, if we look at f of x, this one right here is not a fraction, there's no square root, there's no log, so because it doesn't fit any of these three, the domain is just all real numbers. Easy. What we're also going to do here is find our x and our y intercept. So this is going to require a little bit of algebra. We know that our x-intercept is when our y value is 0. And our y-intercept is when our x value is 0. So we're just going to be plugging these in and solving. So for this one, x-intercept, your y, which is your f of x, is 0. And so we're solving for x in this case. So this is a trinomial. So this one is an x-box problem where we have a times c goes on top, so this is -5. B goes on the bottom, that's 4. What multiplies to give you -5, adds to give you 4, positive 5, -1. Then we have the box. So a goes here, c goes here, and our two values from our x go here. And that gives us 5x minus 1, and then x plus 1. So when we factor this out, we have 5x minus 1 and x plus 1. And those are the two equations that we're going to set up. So 0 equals 5x minus 1, and x also 0 equals x plus 1, and we just solve for x. So we have two answers here for our x-intercept. We have 1/5 and -1, so we're going to write this as a point. So your x value is 1/5, your y value is 0, x value is -1, y value is 0. So those two are my x-intercepts. Now my y-intercept, now my x is 0, so this is easy to do because all I'm doing is plugging in to my x here. So I'm looking for my y, my x is 0, so I'm just plugging into my original equation. So I have 0 plus 0 minus 1, so my y value is -1, and my x is 0, so this is my point for my y-intercept. Okay, let's look at number 2. So let's first find the domain. Again, we're looking at these three situations up here. Number 2 is a fraction, so we're looking at our first situation. When you have a fraction, the denominator cannot be equal to 0. So my denominator here is x minus 5. So if x minus 5 can equal 0, I'm going to solve for x by adding 5 to both sides. I have x does not equal 5. That is my domain. Okay, so to find my x-intercept, just like the previous problem, y is equal to 0, so I have 0 equals my equation, 3x over x minus 5. To solve this problem, I'm going to first multiply both sides by x minus 5 to get it out of the denominator. 0 times x minus 5 is just 0, because 0 times anything is 0. And then when I solve for x, 0 divided by 3 is just 0. So x equals 0. and y also equals 0, so this is my x-intercept. For my y-intercept, now I'm plugging in 0 for x, which gives me 0 over negative 5. My y value is 0, and so my y-intercept is also 0, comma 0, because I know my x is 0. Okay, number 3. So for number 3, I have a square root, so I know this is going to be situation number 2. What's underneath the square root has to be greater than or equal to 0. So x plus 4 is what's underneath your square root. It's greater than or equal to 0. And so solving for x, I'm going to subtract 4 from both sides, and I get x is greater than or equal to negative 4. Which is, if I wrote this in interval form, or interval notation, it'd be negative 4, comma, infinity, with a bracket. Okay, so x-intercept, again, this is when your y is 0, so I'm going to set y equal to 0, solve for x. So in this problem, to get rid of the square root, I'm first going to square both sides, because those cancel out. Subtract 4, so I have x is equal to negative 4. So x is negative 4, my y is 0. This is my x-intercept. And then for my y-intercept, this is when x is 0, so I'm plugging in 0 for x. Simplify, this gives us 2. So 0, and my y value is 2. This is my y-intercept. Okay. So let's move on now to using function notation. So again, we're using equations. A lot of these are just plugging values in. So if we look at A, f of 2, we're just plugging in 2 in for x and trying to find our answer. So when we plug in 2, it turns into 2 squared minus 2 times 2, which is 4 minus 4, which is just 0. Easy peasy. Now we're going to plug in negative 3 in for x, so negative 3 squared minus 2 times negative 3. Negative 3 squared gives you a positive 9, because negative times a negative. Negative 2 times negative 3 gives you a positive 6. Add those two together, you get 15. So see, we're doing the same thing, but now we're plugging in 2x for x. So I'm replacing this x right here with 2x, so now this is 2x squared, minus 2, again I'm replacing this x with 2x right here, and now I'm going to multiply it out. So 2 squared gives you 4, x squared, minus 2 times 2 is 4x. Can't simplify that anymore, so that's my answer. Now for D and E, be careful of where the negative is here. So notice how this negative is outside of f of x. So really you're just putting a negative outside of the entire function. So you're distributing this negative to your entire function. So I have negative this entire thing. When you distribute it, it becomes negative x squared, negative times a negative is positive, x squared plus 2x. Now E, the negative is now on the inside. So I'm going to be plugging in negative x into each of these x values. So I have negative x squared minus 2, again I'm plugging in negative x. So this is kind of like F or C. So negative x squared turns into a positive because negative times a negative is positive x squared. And then negative times a negative is also a positive, so this gives you 2x. And finally, for this last one, now we're plugging in x plus 2 in for x. So we have x plus 2 squared minus 2x plus 2. So this one is a little bit trickier because we're going to have to FOIL this one out. We have x squared plus 4x plus 4 minus 2x minus 4. So I just multiply this all out. Combine like terms, so we have x squared, 4x and negative 2 give you positive 2x, and this 4 and the minus 4 cancel each other out. So this is my answer for F. Okay, Last one. So similar to what we did yesterday, now we're going to be using one equation to answer a whole bunch of questions. So the first question that they're asking us is, what is the domain of f? So domain goes back to these three situations right here. Because it's a fraction, we know the denominator cannot be equal to 0. So we just solve for x. And so we know that the domain is x cannot equal -2. Okay. For b, we're finding f of -1. So this is my x value. -1 is my x value, so I'm going to be plugging in -1 into these x values right here. So f of -1 equals, I have -1 minus 3 and -1 plus 2. And this gives you -4 divided by 1, which is just -4. So f of -1 is equal to -4. And how would I write this as a point? If this is my x, this is my y, my ordered pair would be -1, -4, that's my point. Okay. C is asking us, where does f of x equal 2? So we're looking for when y is 2. So now we're plugging in 2 for my y, which is the f of x, and I'm solving for x. So this is the equation I'm starting off with. So this is a little bit trickier algebraically. Kind of like what we did on the first page, we got to get rid of this fraction. So we're going to multiply both sides by x plus 2 to get rid of this denominator. This one we're going to distribute, so we have 2x plus 4. Over here we have x minus 3. And now we're just going to solve. So we're going to get all the x's on one side. So let me subtract x. This gives us x plus 4 equals -3. And then again we solve for x, so -4 from both sides. And this gives us an x of -7. So that is where your y value is 2. And then the ordered pair, so x is -7, y is 2, so it's written like this. D is asking us, is this point on the graph of f? So here's my x, here's my y. So we're going to check to see if I plug in this x value, is it going to give me this y value? So if I do f of 1, because that's my x value, I plug in 1 for my x, I end up with -2 over 3, which is not my y value here. So no, this point is not on the graph because 1 comma -2 is. Not 1 comma -1/2. Okay, for E, what are the intercepts of f? So we're going to find both the x and the y intercepts. So for your x-intercept, this is when your y is 0. So we're going to set 0 equals your equation. So similar to what we did above, first we're going to get rid of the denominator. Cross those out. 0 times anything is just 0. So this is 0 equals x minus 3. Add 3 to both sides and we get x is equal to 3. So when x is 3, y is 0. That's my x-intercept. My y-intercept is when x is 0. And so I'm going to plug in 0 for my x. So 0 plus minus 3, and then 0 plus 2, which gives me -3 over 2. And that's my y value. So my x is 0, my y is -3/2. And so these are my 2 points for the intercepts. Last two. So for f, we're looking for f of -x. So -x is what we're plugging in. So we plug in -x. Every time we see x, we're putting a -x there. And then -x plus 2. So before it was just the x, now we replace it with a -x, minus 3, -x plus 2. And we can really just leave it like this. There's nothing to simplify. For g, now we're doing negative f of x, so the negative is now on the outside of the entire function. So it's outside of the whole function. And to distribute this, so this negative can only be distributed to one of these. So like if you have like a negative 1/2, for example, you're not saying that it's both -1 and -2, right? Because then the negatives would cancel out. It's really the negative is only on one of your numbers. So we're going to only distribute the negative to the numerator. So this gives us negative x plus 3 over x plus 2. And that can be my answer for g.